Okay, so let's start that over again. Okay, so our midterm exam is Tuesday at 8:30. Plan to arrive at 8:15. That way, if you have to go get a calculator or you have to go to the bathroom or you want to go get your water, all that stuff, we will start at 8:30. Okay. Um, I have to apologize. I really wanted to give you your review sheet today. But at 1 a.m., I finally decided I needed to go to bed. So your midterm is finished. Your review sheet is finished but not printed. Okay. So I will give that to you tomorrow. One of the things that you need to make sure that you know how to do is use your calculator. Because if you can use your calculator, you should be able to zip through your exam. Okay. Okay. Also, a reminder. This is what? This is 12 and 13, I think. Yeah, 12, 13. Okay. Just a reminder. This is a full week of classes. Monday through Wednesday are normal classes, like we always do. Thursday is a full day of school, and you will see all of your classes. Classes will be 40 minutes long. Friday is a full day of school, of course, and you will also see all of your classes. Monday, you will see all of your classes. Okay? So we are revising the schedule for exam review. Okay? Yes.
Are we going to have our flex period tomorrow?
Yes. Flex period, but 11th and 12th grade have a pen service.
Will we,
So we don't get.
they're selling.
So do we get flex on Friday?
Yes, there is flex on Friday. Yes. Okay. Okay. All right. So for your test tomorrow, you need to know the formulas. I'm not going to give you the formulas. Okay. You do not have to worry about simple interest, but you do need to know the compound interest. Let's see. Yes. You need to know okay. So you do need to know those formulas for tomorrow's test. This will be the last test grade. I will be grading your midterm review. So you will have those homework grades, but this will be your last test grade. Okay. Okay. So this worksheet is on Half-Life. Yes.
How many questions on the test?
Tomorrow's test? I didn't make it yet. I don't want to tell you that. I don't want to tell you that.
Like 53.
You guys way too many.
5,730.
That sounds really good. It's like Scottish, it's like 200.
Approximately 60.
That's not bad.
That's
not bad.
She said, how many? 60?
When I make a midterm, I always go back and take it, and I don't use a calculator, and I do it like while I'm watching TV. So last night I did it without a calculator, watching the Dallas game. It took me a half hour. So I usually expect it to take 2 to 3 times as long for students to take it.
So like,
Except for people like Cole. Cole will take it in 20 minutes. Yeah.
And he's gonna get like a 99.
Yeah.
Maybe like one form.
Yeah.
you better watch his negative signs.
Yeah, I'm gonna everything, boy. 10 points off every time he makes a
Yeah, there's
time
no
mistake.
half credit for you.
No.
You're either getting completely
That's
right.
right.
or completely wrong.
That doesn't exactly sound fair, Lindy.
Oh yeah, because God gifts us all differently, so fairness is
It has to
relative.
make it fair through the board of the class. Call you up to match our grades. Exactly.
Okay, so I'm going to go through these examples just because it helps you to understand half-life, okay? So write an exponential function where t is the elapsed time to represent each half-life situation, then use the function to complete the table. So just remembering our half-life formula, okay, n of t, n sub 0 is the initial amount. Okay, r is the rate of growth. And t is the time. So if we look at this, what's the initial amount? 800. Okay, so we got 800. Okay, we're going to leave t alone. It's the r that we need to figure out. Any ideas at how we can do that? We have the what? Okay, so how do I figure out r? How do we know that?
Because it's going down by 1/2 time.
Okay, so each half-life cycle, right, number of half-life cycles, we would expect the growth, the amount to go down by half. So each half-life cycle. So that makes sense, right? Yes? Oh, I got the wrong formula. Oh, my word.
Yeah.
This is T over H. Sorry.
And it's also not E, it's 1/2.
Good job, Cole.
Thank you very much. Wasn't paying attention. I'm sorry, my mistake. Okay, so what's our half-life? Because the formula is going to be n of t equals 800 times 1/2. The t is going to remain a t, right? Because that's our variable time. So what's our half-life? This is a half-life cycle, right? Why 2? How long does it take the bacteria to be half of the amount?
5 minutes.
5 minutes. So our half-life is 5.
Oh, God.
Takes 5 minutes to have half of the previous amount. Okay, now let's fill in the table because we went 5 minutes, 5 minutes, 5 minutes, 5 minutes, and all of a sudden we went 80 minutes. So we're going to use our formula now. So, okay, what?
I wasn't here when you had this out.
Okay, that's a shame.
So,
Yes.
I have a question. So for on the front of this worksheet, when we were doing carbon, it was 5,730 years, and we also just put 5,730. So how come you can put 5 even though it's a different unit of measurement?
It's not because when we solve this, we're actually going to put in minutes. As long as we're consistently using that unit.
Okay.
Right? Good question. So when we get our answer, we need to remember that the time was in minutes. Okay. Okay, so we're going to get 800 times 1/2 to the power of 100 minutes divided by 5. Okay, so 800 times 0.5 to the power of 100 divided by 5. So that gives me a very small number, right? This is 7.629 times 10 to the negative 4th. 7.629 times 10 to the negative 4th, which means it is, let's see, 1, 2, 3, 4, right? 1, 2, 3, 4. 0.007629. Does that sound right?
Sure.
Does it sound correct? Well, let's see. In 25 years, I'm going to have, or 25 minutes, I'm going to have 25 grams, or whatever the unit is here. In 30, it's going to be 12.5. In 35, it's going to be 6.25. Bless you. In 40, we're like 3 point whatever. 45, we're at 1.5. So it's going low, so low that this number is making sense to me. And Cole is checking it now, so we're good. Right? Okay.
I just plugged it in for a different one of them and got the right answer. So.
Okay. How are we going to figure out our half-life cycle? How many cycles, how many half-lives did we do?
Divided by 5.
Right, divide by 5. So that should be 20 half-lives. Okay. Okay. Okay, so let's look at the next one. Okay, so here, again, we're going to use our half-life formula. N of t equals n sub 0 times 1/2 to the power of t over h, right? So what's n of 0? 16, right? That's the initial amount. Okay, looking at the table, how long does it take to get half of that amount? 14 years. 14 years to get half of that amount. That means my half-life is 14. So n of t equals 16 times 1/2 to the t over 14. Okay. Now, we can kind of figure out this number in between. Anybody figure it out? How about this is 1.5 life cycles, which means this is going to be 6. But let's do it using the algebra, the formula. Okay, so n of t equals 16 times 1/2 to the power of 21 over 14. 16 times 1/2 to the power of 21 over 14. 5.656. Okay. So let's adjust this. Does that make sense? It doesn't make sense to me. What did I do? Yes.
How'd you get 1.5? Or like, that's all.
Because it's a half-life of 14 years. So 14 years is 1 half-life. 28 years is 2 half-lives. 21 is exactly halfway between 1 and 2. Right? But why am I getting
I think
5
it has
point?
something to do with it being exponential.
It's around it. You're not allowed to round time. It is years. But so it's not that. This is years. The top one. Sped. It's better to be wrong.
Okay, well, I mean, it is correct. It's just surprising me.
Well, what confuses me, so it decreases exponentially slowly over time, right?
Mm-hmm.
So shouldn't by the time it's halfway to the next cycle, shouldn't it be more than half? No, it is more than halfway to the next part.
Yeah, it is more than half.
So then, yes, it's exponential. Since it's exponential, it goes like this.
Mm-hmm.
So it's slightly more than halfway at halfway
Mm-hmm.
because of the exponential part.
Mm-hmm. Yep. Okay, let's look at the next one. So what's our half-life on the next one? This is grams, right? Yeah, our half-life is 1, so that's nice and easy. So n of t equals n sub 0, which is 1, times 1/2 to the t over 1. So this is a nice easy one. This is just 1/2 to the t. Okay, so to fill in the blank, how much is left after 15,675 years? Okay. Does everybody understand how we're getting this? Okay, so 15,675. Oops.
That's what I got too, and it doesn't make sense to me.
That can't be right. Okay, let me check the settings on my calculator. I've got it as floating.
That's not right.
Wait,
though.
why aren't you dividing it? Why aren't you dividing it by 5,700? Like, why isn't that?
Oh my gosh. See, this is what happens when you don't get enough sleep.
Just take a nap break.
This is why you have to get enough sleep before your exam.
That's what I was wondering why we were doing that.
Okay, yeah.
Good job.
Was that just too small of a number for the calculator to work with?
Yes. It's taken zeros out so far. Okay, so this is going to be our half-life is not 1. Our half-life is 5,700. Good job. Gee whiz. Wow, I am really tired. Okay, so this is 1/2 to the 15,675 divided by 5,700. That makes more sense. Wow, you gotta get sleep. Brain is not functioning. Okay, so this is 1.4865. 1.4865 times 10 to the negative 1. When you have a negative exponent, you move your decimal to the left. So this comes out to be 0.14 or 15. We'll round it to 15. Okay. How many half-life cycles? We need to divide 15,675 by 5,700. I guess I would have seen it when we got to that point, huh? 2.75 half-life cycles.
You should probably change your calculator back to mixed scientific notation.
Yeah. Okay. Okay. Yes.
Did I plug something in my calculator wrong? 'Cause I got 0.148 like right off the bat.
No, she just said it's a scientific notation.
Yeah.
Okay.
Okay. Did we did the population growth one, right? Okay. The NERT one? Okay.
and that one we didn't pay compound.
Really? You guys did all that?
Yes, sir.
Why is it? Oh wait, never mind.
I'm just kidding.
It's cake. It's tiger. Laugh at stuff.
Okay.
150. 0.1. Is that the answer?
Okay, so let's see. Blah, 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 blah. Let's write our half-life formula, right? So we're looking at n of t equals n of 0 times 1/2 to the power of t over h. Okay, so a 100 grams of carbon-14 decays until only 25 grams of carbon is left after 11,460 years. What is the half-life? Oh, gee whiz. I am so sorry.
This is too easy.
You just divide by 2.
Yeah, just
Well, I haven't taught you how to solve for the exponents.
We just
You don't need to.
Okay.
Okay.
That's why we were arguing.
So-
that's why we did not understand.
So we've got, okay, 100 grams, that's our initial amount, times 1/2, okay, until only 25 grams are left. Oops, so this should be 25 equals 100. This one you can solve without the logs. To the power of 1/2.
Yes.
Half-life is, we're looking for the half-life. So we're looking at 11,460 over h. Is that right? Let's see. This is my initial amount. This is my final amount.
Miss Murray, you don't need to use that though.
No.
I would like to
Us
see it
anymore
from
than
my
we
team
have.
side.
But it's so easy.
You just divide
You think everything's easy,
by 2.
easy
Yeah,
and it's
sure.
not,
Okay.
and it's not.
But I'm
Okay.
getting the right answers. I Googled them and they're correct.
Because Google was correct.
All right. So if I divide by 100 on both sides, I get 1/4 equals 1/2 to the 11,460 divide over h. Does everybody understand that step?
Yeah.
Okay. So 1/4 is 1/2 squared. Does everyone agree with that? Everybody understand how I did that? Okay, so there's a property or rule that says when we're solving exponential equations, if I can get the same base on each side, then I can set the exponents equal. That makes sense, right? If we have the same, 1/2 to the second is the same thing as 1/2 to the 11,460 over h, then 11,460 over h must be equal to 2. So we can solve this. And remember your trick for solving these type of equations, just switch your h and your 2. So h equals 11,460 divided by 2. And what does that come out to?
5,730.
There you go.
But Miss Murray,
Now, some of you just reasoned that through, and that's fine.
you do that
Absolutely.
for all of them.
Okay, but we're going to do it this way because we need to practice and learn how to do the exponential equations. Okay. So that means we figured out the half-life to be 5,730 years, right? Because we're talking years. Okay. Okay, next one. What is the half-life of 100 gram sample that decays to 12.5 grams in 21.6 seconds? Okay, same thing. So n of 0 equals 100. N of t equals 12.5. And our time is 21.6 seconds. Right? We're trying to figure out the half-life. So we have 12.5 equals 100 times 1/2 to the 21.6 divided by h. Okay, 12.5 divided by 100 see if this works. What is that, 1/8? Okay, let's see. Oops, didn't mean to do that, sorry. 12.5 divided by 100. Okay, 1/8. Let me take this back off here. After I got my answer, I just pressed math and then chose the first option to fraction. Okay, so that's nice because 1/8 equal to 1/2 to the power of 21.6 over h. So how am I going to solve this one? Can I write 1/8 as a power of 1/2? What is 1/8 as a power of 1/2? To the third, right. Okay, so that means what?
Take away the fraction.
Right, that means that 3 is equal to 21.6 divided by h, which means h is 21.6 divided by 3. And we get 7.2. So we're looking at h equals 7.2 seconds. Okay? How are we doing? It kind of makes sense all of a sudden, right? Okay, see if you can do the next one. Man, I have a bellyache. I do want you to set it up like this. Please don't just do it in your head.
Yes, sir. So would that divide the 100 by 8?
Say again?
Would you divide the 100 by 8?
You divide the,
Which one?
yes, 100 divided by 800.
And 0.
Okay, so what's n sub 0? 800. What's n of t? 100. Okay, n of t is 1. So here's my initial amount. Here's my final amount. What is h? I'm sorry, what is t rather? 639,000. Okay. So we're looking for h. Okay, so we have 100 equals 800 times 1/2 to the power of 639,000 over h. So this is going to be 100 divided by 800, which is 1/8 again. So we have 1/2 to the third equals 1/2 to the 639,000 divided by h. So see, we just learned how to solve some basic exponential equations, right? And this is a really simple way. If you can get those bases the same, we're in good shape. What we're going to learn after Christmas is what to do when we can't get the bases the same. All right, so h equals 639,000 divided by 3, which is 213,000. And this is in years. So half-life is 213,000 years. Okay? Okay, let me see if there's anything different on here, on this worksheet. Yeah. So if you can't solve the equation, you can stop at this point here. or I should say stop at this point here, okay? If you have an equation that you cannot solve using the method we just used, then you can stop with just the equation, okay? But I'd like you to finish this worksheet. Does anyone have questions on what we just did?